Hello and welcome back to another episode of Math with Sohn. Today, we're going to be taking a look at Pascal's triangle and figuring out how to use it to expand a binomial expression, which can be very useful, especially if you had to expand something that was like x to the third or x to the fifth or even bigger, okay? But before we get into that, it'd be kind of important to look at the triangle and understand how and where and what the heck is even going on, because you normally aren't given the triangle. You have to be able to make it yourself. So you always start with 1, and the 1s are lining up all the edges, and that's why we have a 1 and then a 1 and a 1. And to get the middle chunk, you would do 1 plus 1 to get 2, and then 1 plus 2 to get 3, and 1 plus 2 to get 3, and then 1 plus 3 to get 4, and 3 plus 3 to get 6, and 3 plus 1 to get 4, and then the 1s are on the edge again. And you keep doing this pattern where you have 4 and 6 make 10, and 4 and 6 make 10, but then you notice these 5s on the outside. That's because 4 and 1 add together to make 5. And we're going to keep going because sometimes we need to go a little further than what we have here. So if I had 1 and 6, I would add those together to get 7. And then the 1 on the edge, and then the 6 and the 15 would add together to get 21. The 15 and the 20 would add together to get 35. 15 and 20 would add together to get 35. 6 and 15 would add together to get 21. 6 and 1 add together to get 7. And then the 1 on the edge. And it's always symmetrical, which is kind of nice. It's beautiful. The Pascal's triangle is used in a lot of different ways. Today, we're only going to use it for binomial expansion. And we'll do one more layer. 1 plus 7 is 8. 7 and 21 make 28. 21 and 35, if you add those together, get 56. 35 and 35 get 70. 35, 21, 56. It's going to be symmetrical from here out. So we got the 28 and the 8. And then the 1s on either end. That is always going to be consistent with the 1s following up everything. So that's Pascal's triangle. We use these numbers. We use these numbers as the coefficients for each term when we expand something like a plus b to the fifth. Okay? So I'm going to use this as an example. So see how here, a plus b to the fifth, we first off used the line that had a 5 here. Versus a plus b to the third, we used the line that had a 3 here. And then the a plus b to the fourth, we used the line that had a 4 here. So that tells you which line to use. And we also can look at it. It's going to start out with the first term, a to the fifth, and then it's going to drop by 1 and be a to the fourth, and drop by 1 and be a to the third, and drop by 1 and be a squared, and drop by 1 and be a to the first, and drop by 1 and have no a's at all. Meanwhile, the second term, the b, over here on the right, started with 5, and then had 4, and then had 3, and then had 2, and then had 1, and then had none. So that's how those are occurring. And you may also notice that the 5, the 10, the 5, and whatnot, they all came from here. And this was a 1 a to the fifth, so that's a 1. And then a 5 a to the fourth b, because it was a 5 here, and then a 10 because it was a 10, and then a 10 which was a 10. Now, if there was a number in front, let's say that this was a 2a, then it would be 2a to the fifth and 2a to the fourth times the 5. So these 5, 10, and whatnot, they're going to be there forever, and they would multiply by with whatever we get. Okay? So I think we're ready for an example. Let's do an example, ladies and gentlemen. Let's do x, because x is more friendly with what we're familiar with. Let's do x plus 3 to the 6th power. So if we had to do x plus 3 to the 6th power, first off, what I would do first is start with the obvious. So this a to the 5th, a to the 4th, a to the 3rd is going to be x to the 6th, 3 to the 0, I like doing the 0 power, plus x to the 5th, 3 to the 1st, plus x to the 6th, but I can't count, drop it by 1, x to the 4th, 3 squared, plus x to the 3rd, 3 to the third, plus x to the second, 3 to the fourth, plus x to the first, 3 to the fifth, plus x to the 0, 3 to the sixth. Barely fit it in one screen. Holy moly. Now, that, ladies and gentlemen, is just following the powers. So if it started with a 6 power, which ours did, then it's 6 and 0, then 5 and 1, and 4 and 2. They will always add to 6, which is another key, nice little feature here. And I like doing it forwards and backwards. So we got 6, 5, 4, 3, 2, 1, none. 6, 5, 4, 3, 2, 1, none. All right. So far, we have done that part, but we have not influenced Pascal's triangle at all. If we wanted it to be the 6th power, then we need to look at Pascal's triangle to get the 6th line down, which would be this line right here. So when I do my next step, I'm going to utilize the 1, 6, 15, 20, and all that, okay? So it is going to be a 1 x to the 6th. 3 to the 0 is just 1, so it's 1x to the 6th. Plus 6 x to the 5th times 3, which in the next line down I'm going to actually multiply by 3, plus 15 x to the 4th times 9, because 3 squared is 9, plus, next up we got 20 x to the 3rd times 27, which is what 3 to the 3rd is, plus, next we got 15, again, x squared times 81, because that's what 3 to the 4th is, plus 6 x to the 1st power, 3 to the 5th, I don't know that one, 3 times 3 times, why don't I just write 3 to the 5th? 3 to the 5th is 243 times 243, and then x to the 0 is just 1, so 3 to the 6th power is 729. And there it goes, it finally fit. So, all of these, this is technically almost the right answer. It's always a plus in the beginning, and then based off of what you get from here will determine if it ends up being minus or whatnot. So these are all going to be plus because 3 times 6 and 9 times 15, all of those actually equal positive numbers as well. So I'm going to rewrite my answer. X to the 6th plus 3 times 6 would be 18x to the 5th plus 15 times 9, 15 times 9 is 135x to the 4th. And then 20 times 27 makes plus 540x to the 3rd. And then 15 times 81 is plus 1215 x squared. And then 6 times 243 is plus 1458 x to the 1st power. All I'm doing is multiplying 6 and 243. And then last but not least, 729. Boring. So this big, long, stretched out thing is our answer, which might have taken forever, but at the same time, it's still not that bad compared to what would happen if you actually multiplied x times 3 times x plus 3 times x plus 3 times, if you multiplied all those together, okay? Now, this was actually a relatively easy one. In another video, I am going to go through how to deal with these two type of problems. So if you're looking for something like x minus 2, believe it or not, a minus to the 5th power or anything like that would actually influence the problem a lot. Or if you have a 2x and maybe a 3rd power plus 5. So if you have a 2x, not just a 2x or like an x, then that actually influences the problem a lot as well. So I'm going to do another video on how to deal with problems that look like both of these, but I wanted to keep this one short and focused and like just barely how to use it, okay? Till next time, ladies and gentlemen, I will see y'all later. Bye.